Today I'm going to continue on basically using a code from yesterday's project to do something a little bit different and to demonstrate a couple other features of Rust and patterns. So today what I'm going to do is build another PNG image, but this time I'm going to build one from the output that we get from a random number generator that we write. And we're going to use the KISS random number generator. The KISS random number generator, I think, was developed or invented in 1993, maybe. Not sure if it says here. Maybe 1993. There's some papers on this. So anyway, the algorithm that we're going to use a 64-bit one on the right here. For some reason, this pseudocode / C code is only in the German version of Wikipedia. So not sure why. Never noticed that there was a lot of differences before, but apparently there are differences. Anyway, I'm going to try to keep this real quick, so I'm going to just be doing a lot of pasting of the code instead of typing everything in individually. So I'm going to go ahead and start a new project. Call it static KISS, because we're going to make some static with a KISS algorithm. Go in there. First thing, obviously, is I need to bring in that image dependency, which is just called image. Nice and neat. Save that, and then let's bring up so you saw the algorithm there, so there's a bit of stuff that we need. We're going to need the crate stuff, as well as set those constants and also the size of our image. So I'll just paste that in. So here we have some static variables. I made them public so we can document them later, and they'll show up. They're kind of important, especially the first one here, which is essentially the seed. Cannot be 0. And then, yeah, the rest of the stuff is public, because eventually we'll get into handling command line arguments, things like that, but it kind of takes away some of the fun doing that gunk. Okay, so again, just like yesterday, we create an image buffer image, and we just kind of use that little closure trick and the image buffer function. So there that is. Again, this check, the only reason we're doing this special check here is to make sure that one of the pixels is all black, this first one here, so that we can use it later at coordinates 0, 0. So we'll just go ahead and bring that in. Call that our pixel. 0, 0. Close it out. All done. Then we'll do a little for loop. Go 0 to width. Oopsie. So here we're just going to do even and odd, and when we're even, we will go ahead and make the pixel black. Again, we're kind of just using this random number generator, which is generating these really huge 64-bit values to get heads or tails. And there is the program. And if you remember from yesterday, to write this out as a PNG file using the image class, we simply use this pattern here. We get a file descriptor, and then we save it out using the image and then the color plane model, color model, and a save function. Okay. Then we'll introduce our random number generator right from the wiki page. We'll return a usize instead of a U64, and that's because I was unable to get this to work. Some of these operations aren't allowed on normal, on 64-bit value, so we have to just use the word size here. The word type. uint is a primitive in Rust. Okay, so you're probably wondering, a couple things are different here. They're kind of Rust-isms. One is I'm doing unsafe. I'll show you why. We need that later. And then I also don't have a return. Instead, I'm just omitting the semicolon on the end. And if you omit the semicolon, then that becomes the expression. So the function will basically just emit the result of x plus y plus z or z. So let's just see if this builds first, because that takes a few minutes because we have to build all the dependencies. Okay, all done there. Now I'm going to run this and see if we get an image. Let's just do cargo run and I'll show you what's going on here. Look at that, it crashed. So now we're already fighting a problem here. So it says we main panicked, attempted to multiply with overflow. Well, this algorithm, it definitely uses overflow to an extreme. So that was expected. So it turns out that in Rust, when you are running in debug mode or just the default cargo run or cargo build, when you build your debug image, those binaries do not run if there's any overflows. I guess it's just sort of a way of separating it. So it turns out it's kind of ironic a little bit in that, but if you run it with release mode, with the stripped and optimized binary, then it's considered okay. So what this means is that if I was going to test this, I would probably need to have the, in my test build scripts or whatever, I guess I would turn the backtracing on. And, well, I don't know. That wouldn't actually work either. Never mind. So, yeah, basically we'd have to test with the release version. I'm going to have to do some more research on that. Oh, cargo run dash release. Okay, and then we have to recompile everything because we have to compile the optimized version. I think my processor is 3.5 gigahertz, but it's still taking a while. And it's on an SSD, so anyway, this is just a lot of lines to compile. And should be done any second now. There we go. Okay, now we should have a image to look at. Should be, there it is, file static, should be 700 by 700, 8-bit grayscale, yep. And then we can do a, I called it static. And there we go. Well, I don't see any anomalies in there or any patterns or Moya or whatever patterns, so looks like it worked. We have some random numbers. And I did some performance testing on this, and it is very, very fast random number generator. It does tens of million random numbers per second. Very little CPUs required, very little memory. So it's pretty neat. Let's see, I think that's it. Hope you like this. I did want to show you one more thing, I guess, because what happens if we didn't use unsafe? Just in case you get this message. just go ahead and build this. Get a whole bunch of errors here. And the error says use of mutable static requires unsafe function or block. So, you know, the reason we're using statics here is that we want to keep calling this function kiss, and we want the results to be different each time. So we're using all of these mutable statics because we're changing all of these variables over time. And that's considered unsafe by default, but it's actually what we want with this particular function, at least as implemented. We can probably refactor that sometime. That might be another project when we talk about doing it the Rust way instead of the C way. So that is it. Again, I hope you... Oops. Let's fix this up. And just run it one more time to make sure everything's fine. All right. Put back my unsafe block here. And that's all done. Cargo run -- release. And still back to working again. Okay. All right. Thanks everybody, and feel free to I'll put the GitHub URL so you can clone it and play around with it if you want. Hope this was worthwhile. Take care.